Welcome to my presentation on starvation in database management systems. In DBMS, starvation arises when transactions or processes are deprived of resources or experience delays. This significantly impacts system performance and transaction processing. Now let's delve into the causes of starvation in DBMS. First, we have concurrent transactions. Concurrent transactions competing for limited resources can lead to starvation, where some transactions are deprived due to resource contention. Second, we have locking mechanisms. Poorly implemented locking mechanisms may cause certain transactions to wait indefinitely for resources to be released. This increases the risk of transaction. And the third, we have resource allocation. Inefficient or unfair resource allocation can impede the timely distribution of necessary resources, resulting in some transactions not receiving what they require. For the profound effects of starvation in DBMS. First, we have delayed transactions. Starvation often leads to delayed transactions, significantly impacting their execution time and potentially introducing inconsistencies within the system. And then we have the reduced system performance. As certain transactions experience starvation, the overall system performance is compromised. This results in slower response time and a noticeable degradation in efficiency. Now let's discover how to prevent starvation in DBMS with these effective strategies. First, we have the deadlock detection and prevention algorithms. Utilizing this algorithm enables the identification and resolution of scenarios prone to causing starvation. Thereby, this safeguards system processes. The second strategy is priority-based scheduling. When implementing a priority-based scheduling algorithm, it ensures equitable resource access for all transactions. This mitigates the risk of certain processes being starved or for essential resources. Let's explore some real-world scenarios highlighting starvation in DBMS. The first scenario is data center overload. In overloaded data centers where resources aren't allocated effectively, certain transactions might face starvation due to insufficient access to necessary resources. Second, we have long-running queries. Complex and lengthy queries monopolizing databases resources can lead to delays or starvation for other transactions awaiting those same resources. The third scenario is contention for shared resources. In a multi-user environment, contention for shared resources like disk space or network bandwidth can trigger starvation scenarios where some transactions are hindered due to resource competition. In conclusion, starvation in DBMS significantly impacts transaction processing and system performance. However, by comprehending its causes and deploying preventive measures like priority-based scheduling and deadlock detection algorithms, we can effectively mitigate risks and uphold optimal system operations.